Hello students, welcome back to our channel Abhyas IT Prep. In this video, we are going to discuss about the 24th Jan evening shift paper. Let's get into the video. See here, question number 26 based on the equivalent resistance which is from current electricity. What they are saying, see here, section A, the reading of ammeter. You have to find the reading of the ammeter in steady state. The following circuit, you have to just find the reading of the ammeter. Reading of the ammeter in steady state. Okay, see here, what is the steady state condition? In steady state, the capacitor is open circuit. If you draw this one, redraw this circuit. Okay, this is 10 volts, 1 ohm, 4 ohm, 8 ohm and 8 ohm, one more 8 and 8 ohm. Okay, this is open circuit. We are not considering this term. If you calculate this one, this is 8 by 2, that is 4, and 4 plus 4, 8. So you are having this is 9 volts and 1 ohm. This is 8 ohms. We are having one more 8, and this is our ammeter. This is 8 ohm and 8 ohm. This is our 10 volts. I am taking 9 volts. So if you find the equivalent resistance, we are having R equivalent can be written as 5 ohm. So I can be written as 10 by 5, that is nothing but 2 amperes. So in this circuit, we are sending a 2 ampere current. 2 ampere current. So see here, we are sending 2 ampere current, and this is passing through 2 branches. One branch we are having 1 ampere, and another branch we are having 1 ampere. So at this place also we are getting 1 ampere current. So what is the reading of ammeter? So that is nothing but 1 meter. Option 1 is the right answer. So next question, see here. Question number 27. In vernier calipers, 50 vernier scale divisions are equal to the 48 main scale divisions. If a main scale divisions is 0.05 millimeter, then the least count of the vernier calipers. What is the least count formula? Least count can be written as 1 main scale reading minus 1 vernier scale reading. 1 main scale reading minus 1 vernier scale reading. So see here, 1 main scale reading minus vernier scale. How much? 45 main scales per 50. 48 by 50. 48 by 50 into what is the 1 main scale division, that is a main scale reading. If you observe, you will get 2 by 50 into main scale reading, that is nothing but 2 by 50 into 0.05 millimeters. So after that you will get a value 0.002 millimeters. Option 1 is your answer. Next question, see here, 28. So 5 persons P1, P2, P3, P4 and P5 recorded object distance U and image distance V using the same convex lens. Same convex lens having power 5D. Having power 5D as they have given values respectively. Identify the correct statement. Identify the correct statement. So see here. Identify the correct statement. What are the statements? Readings recorded by all persons are correct. Reading recorded by P3 persons are incorrect. Reading recorded by P3 and P2 persons are incorrect. So reading recorded by P4 and P5 persons are incorrect. So you have to find the which is correct. We know that one, when object is placed, when object is placed between F and 2F, between F and 2F, and image should be formed beyond 2F, beyond 2F. Remember this. This is case 1. If case 2, what is that one? If object is placed beyond F2, beyond 2F, not F2, 2F. Image is formed between 2F and F. 2F and F. You have to remember these conditions. How to find F? So power can be written as 1 by F, that is nothing but 5D. So if you find F, you will get what you are getting? You are getting 20 centimeters. You are getting 20 centimeters. So F is 20 centimeters. F is 20 centimeters. 2F is nothing but 40 centimeters. What is the condition here? If object is between F and 2F, that is nothing but F is nothing but 20 centimeters, 2F is 40 centimeters, between these two, then beyond 2F. So image is forming at greater than 40 centimeters. That is the condition. Second one, object beyond 2F. So greater than 40 centimeters, images are forming between 20 to 40 centimeters. Forming between 20 to 40 centimeters. This is our condition. So if you observe the values, you will get the answer as 2. So see this one, person 3. This is our, what is this one? Object distance is 35. 35 is between F and 2F, is between F and 2F. What is the image distance? That is 37. 37. 37 also between F and 2F. This is wrong. You must add beyond F, that is greater than 40 centimeters. That is the condition here. Next question, see here, 29. A regular hexagon is formed by 6 wires of each resistance R omega. The corners are joined to center by the wires of same resistance. If the current enters at one corner and leaves at the opposite corner, the equivalent resistance of hexagon between 2 point corners. Take this one, hexagon. Consider this is our hexagon having 2 points, point A and B. This is our center. These are the resistors. Resistance, 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 resistors. If you redraw this as per our question, you will get this is one resistance R and this is R. You will get 2R in the middle. One more is there. Okay. R, this is total, this is also R. Similarly, we are having one more arm here. I am finding this one. No need to consider this one. After that, we have to consider. So this is 2R. This arm is 2R and R. So how to find here? Take this 1, 2, 3. For R1, let how to find 2R into R by 3R. RR gets cancelled. 2R by 3. This is our 2R by 3. So see here, this is 2R by 3 and this is our R and one more R here. 2R. So consider here, take this one from this one. R equal to R equivalent, that is series combination 2R plus R, 2R by 3. So 8R by 3. 8R by 3. I am writing here. So this is our middle arm, that is 2R. One more upper one is there, that is 8R by 3. Below one is also 8R by 3. These three are parallel to each other. So for parallel combination, R for parallel combination, 3 by 8R plus 3 by 8R plus 1 by 2R. So take LCM, 8R, 10 by 8R. 10 by 8R. So you can simply write 5 by 4. 5 by 4. Okay, this is R parallel. So you will get 4R by 5. You will get 4R by 5. So next one, see here. Question number 30. In case of vertical circular motion of a particle by the thread of length R, if the tension in the thread is 0 at an angle 30 degrees as shown in figure, the velocity at bottom point. This is making 30 degrees. So what is this one? This is, take this length as a total length. This will be your 60 degrees. Then you can write this is mg sin 60 and this is our mg cos 60. What do you have to find? You have to find the velocity at the bottom of the circular path. Mass is acting downward, that is nothing but mg. In equilibrium position, t plus mg cos 60 equal to mv square by L. This is 0. Tension in the thread is 0. So from this one, mm gets cancelled and cos 60 is 1 by 2. So g by 2 v square. So L can be written as Lg by 2. This is our v square value. Now, okay, see here, law of conservation of energy is can be written as half mu square is nothing but mgl 1 plus cos 60 plus half m v square. Cos 60 1 by 2, 1 by 2 plus 1 3 by 2. So mm gets cancelled, m and half also. Okay, I will write here half also you will cancel. So 3gl plus v square. What is the value of v square? gl by 2. gl by 2. See here, 6 plus 7 gl by 2 v u value. This is under root. Okay. 7 GL by 2. 7 GL by 2. L is nothing but length, that is R. You can write here R also. No worries. So question option is your 2. So next question, see here, a thin uniform rod X of mass capital M and length small l is pivoted at height L by 2 as shown in figure. The rod is allowed to fall from a vertical position and lie horizontally at the table. The angular velocity of the rod when it's hit the top. When it is going down, when it is hitting top, at that point you have to find the angular velocity. So at potential energy is equal to kinetic energy. Potential energy is nothing but m g h. H is nothing but L by 3. L by 3 half I omega square. You have to find omega square. So see, I from parallel axis theorem, ICM plus m d square. How to find a d? So d can be written as half of the length. So from L by 3 minus L by 2. From this one 6. L by 6 is our d. We know that one I centimeters is nothing but what is the moment of inertia through the center of mass? ml square by 12 plus ml square, that is nothing but ml square by 36. So if you see here ml square by 9, this is our I. Substitute here mgl by 3 equal to half into ml square by 9 into 9 into omega square. Okay, this is our 3 and mm gets cancelled and L. So if you observe there, omega can be written as 4G by L. 4G by L. So sorry, 6. This is 2 into 3. 6G by L under root 6G by L. So sorry. Here we are having 6 because mgl by 2. We know that one mgl by 2. But what is the length here? L by 3. So L by 2 into 2, you will get 6 here. That's why this is our 6. Okay, 3 by 2. So you are having the value is nothing but, see, or having the value G by 2L. Option 2 is your answer. So next question, see here, 32. Two identical circular loop P and Q, each of a radius R, lying in parallel planes such that they are become common axis. They are having common axis. The current through the P and I and I1 are respectively in clockwise direction. So P is having I current and Q is having 4I current in clockwise direction as shown in figure. The net magnetic field at O. So see here at this one, this is B2, take this B1. So B net can be written as B1 minus B2. B1 minus B2. So from this one, mu naught I B1, that is 4I by R square, X square, that is nothing but R square by 2 into R square plus R square whole to the power 3 by 2 minus mu naught I R square by 2 r square plus r square whole to the power 3 by 2. So from this one 3 mu naught I r square by 2 into 2 r square whole to the power 3 by 2. From this one you will get 3 mu naught I by 4 root 2 r. This is your answer. Towards Q. It is moving towards the Q value. So next one, see here. Question number 33. When a light of a given wavelength falls on a metallic surface, the stopping potential is given. Stopping potential they have given. If the second light having a wavelength twice of the first light is used, stopping potential is drops to 0.7 volts. Then the wavelength of the first light is. Wavelength of the first light. So we know that one. 32 volts stopping potential can be written as Hc by lambda minus 5. This is first condition. And 0.7 volts is nothing but Hc by lambda minus 5. This is the second condition. If you minus 1 minus 2, you will get 2.5 volts is nothing but Hc by 2 lambda. They have given twice. Falls on the metallic surface. Second light is having a wavelength twice of the first light. So you will get a Hc by 2 lambda. Hc by 2 lambda. Q into, okay. So by 1 by E. If you see here, Hc by E 1 by 2 lambda. Hc by E can be written as 12400 1 by 2 lambda. 1 by 2 lambda, 2.5 volts. 5 lambda can be written as 2 to the power 5. 12400 by 5. You will get 2, that is 24 and 80 meters. So 2480 angstroms. So from this one, if you want to find 2.480 into 10 to the power minus 7 meters. 2.4 10 to the power minus 7 meters. Option 4 is your answer. Next question. Question number 34. The fifth harmonic of a closed organ pipe is found to be in unison with the first harmonic of open pipe. Unison means equal. The ratio of lengths of closed pipe to that open pipe is 5 by x. Then find the value of x. For closed organ pipe, this is closed is equal to fifth harmonic. So that is fifth harmonic is equal to the first harmonic of the open organic pipe. So what is that ratio of lengths of closed? So closed by open can be written as 2 by 5. This is nothing but 5 by 2 here. We are having 5 by 2. 5 by 2. What is the value of 2? X is nothing but 2. Next question, see here, 35. This is bit difficult. A lengthy time taking process. Not difficult. It will take much time. I will solve one. Otherwise, I will solve one. After that, you have to find the remaining and you have to mark the answer. So, 3 parallel plate capacitors are there. Area and separation D filled with 2 dielectric constant K1 and K2, and K1 is greater than the K2. So what is the capacitor B is greater than C and C is greater than A. These are the conditions. First you have to find the capacitance. So capacitance for A, see here I am taking diagram here. Half you are having K1 and this is K2 and this is again K1. This is a D by 2, D by 2, A by 2, A by 2, this is A. I am finding for this one, that is a first and second. Okay, first one, capacitor C1 can be written as K1 epsilon naught E epsilon naught A by D by 2, I am writing here 2. For case 2, C2, those two are parallel to each other, that's why I am adding those two. So see here, K1 A by 2 epsilon A by 2, D is also D by 2. So see here, A by 2, D by 2 can cancel this. K1 epsilon naught A by D. Similarly, you will get for K2 also. K2 also you will get so K2 also similarly you will get plus I am writing here. What is C2 value? I am writing finally K1 plus K2 into epsilon naught A by D. This is our C2 and C1. These two are parallel to each other. So what is the parallel condition? C parallel can be written as C1 C2 by C1 plus C2. See here, C1 into C2, 2K1, K1 plus K2. Take this one, this is C, CA, that is CA into CA by 2K1, that is nothing but 3K1 plus K2 into CA. If you cancel these two, you will get the CA value. If you find CB and CC, you will get the option CA is greater than CC and CC is greater than CB. So next one, see here, question number 36, the binding energy of the following nuclear reactions. They have given helium and H. They have given some reactions. X3 and X4 and X5 are belongs to helium 3, helium 4, helium 5 respectively. Then the correct order is, how to find the correct order? I will tell you. So see here, first reaction, binding energy of He4. I am taking this He4. He4 minus binding energy of He3. I am writing here 20 mega electron volts. Similarly, second reaction, the binding energy of He5 minus binding energy of He4 is nothing but minus 0.9 mega electron volts. If you observe these two equations, in this case He4 is greater, that's why we are getting positive sign. In this second case also we are having a negative sign to the helium 4, that's why we are getting negative. So from this one, B3 and B5 is much less than the this helium 4. So H4 is greater than H3 and H5. In this case, see here, in this case we are getting negative sign, but we are getting positive sign there. What is the condition here? So He4 5 is greater than as compared to H3, because we are getting 20, here you are getting 0.9, and which is greater than HE. Option 3 is your answer. Option 3 is your answer. Okay. So, sorry, option 4 is your, option 4, is that right? Okay, option 4 is your answer, descending order. So, next question, see here, 37. A cubical block of a density rho b 600 kg per cube floats on a liquid of density 900 kg per cube. If the height of the block h is 8 centimeters, then the height of the submerged part. So, see here, what is the condition? We are having a cubical block which is floating in a liquid of density rho liquid. This is density rho solid. Take this one. What is the block height? Block height is capital H. Then you have to find the submerged part of height. Small h you have to find. At equilibrium, this gravitational force mg is acting downward and buoyancy force is acting upward, Fb. So see here, okay, see, weight mg equal to Fb, buoyancy force. M can be written as rho into volume, that is nothing but rho of a solid into volume is nothing but, what is volume? Height into area into gravity. What is F? Buoyancy force, rho GH into area, rho GH into area. So see, this is a liquid density, sorry, liquid density. ZZ gets cancelled and AA gets cancelled. Okay, we have to find H. H can be written as a capital H into density of a solid by a density of the liquid. You can write 8 into density of the solid, that is nothing but 600. We are having 900. Cancel these two and you are getting 2 and 3. 2 and 3, that is nothing but 16 by 3. 16 by 3. So almost 5.3 centimeters. 5.3 centimeters. This is your answer. Next, 38. A moving coil galvanometer of a resistance 100 ohm shows a full scale deflection of current 1 ohm. 1 ohm. The value of a resistance required to convert this galvanometer into ammeter showing a full scale deflection of current 5 milliamperes. So for ammeter you have to connect R, resistance R is parallel to galvanometer. This is your condition which is taking 5 milliamperes. You just need galvanometer 1 milliampere and this is our 4 milliampere. Okay, so you have to find the required resistance. Resistance R can be written as G by G resistance is 100 ohm. 100 ohm. G by I by Ig minus 1. I by Ig minus 1. What is G? 100. What is I? 5. What is Ig? That is 1 milliamperes. 1. So you will get 25 ohms. Option 1 is your answer. 100 by 4, 25 ohm. Next question, question number 39. The correct truth table. First you have to find the output. This is our A. No need to worry. This is our B bar. Here also you are getting B bar. So what is the output here? A dot B bar. This is our output. A bar dot B bar. Look this one. A, that is 0. B bar is nothing but B is 0. B bar is nothing but 1. You will get 0. Okay, this condition is satisfying. One more is there. 0. B bar 0. But you are getting 0. But here we are having 1. Second one. 0, 1. That is nothing but 0. But we are getting 1 here. Option 3. 0 dot 1. You are getting 0. But you are having 1. So remaining option 4. You can check. Next question. Question number 40. A flexible chain of mass m hangs between two fixed points at the same level. The inclination of a chain with the horizontal at the 2 points of the supports is 30 degrees. So we are having a chain at 30 degrees inclination. This is our 30 degrees inclination as with the horizontal. Okay, consider the equilibrium of each half of the chain, then the tension of the chain at the lowest point. Take this lowest point, at lowest point or at half of the length, mass you are having, half of the mass you are having. This is our tension at lowest point, tension at highest point, T. Take this one. This is our, if you resolve the forces, you will get T cos theta, cos 30, that is nothing but, and you are getting T sin 30. So see here, at the equilibrium condition, T sin 30 equal to mg by 2, gravitational pull. T cos 30 equal to, this is a T naught. So tan 30 can be written as mg by 2 T naught, but you have to find the T naught. This is the value of 1 by root 3. So see here, 1 by root 3. So root 3. So T naught equal to root 3 by mg. Root 3 by mg. Root 3 by 2 mg. This is your answer. Option 1 is your answer. Next question. 41. A point source is kept at center of the spherical enclosed detector. If the volume of the detector is increased by 8 times, initial volume is V and it is increased by 8 times, the intensity will be. Intensity formula, we know that one. Intensity can be written as, intensity is nothing but power by area. Power by area. So intensity is inversely proportional to area. So that is a spherical enclosed detector. Volume is 8 times. Then what will happen to R? R can be 2 times. That is 2R. How to find area? Area is nothing but 4 pi R square. So area is increased by 2R square times. Area is increased by 4R times into 2. That is nothing but 4R. Okay. So what is this one? Intensity is decreased by 4 times. Intensity is decreased by 4 times. So next question, see here. Next question. Question number 42. In Young's double slit experiment, the intensity produced by each one of the individual slits is I naught. The distance between two slits is 2 millimeter. Distance between two slits is small d can be written as 2 millimeters. That is nothing but 2 into 10 to the power minus 3 meter. The distance of a screen from the slit, capital D, is nothing but 10 meter. The wavelength of light, so lambda can be 6,000 angstroms. This can be written as 6,000 into 10 to the power minus 10 meter. The intensity of the light on the screen in front of the one of the slit. We know that one. This is our slits. 1, 2. This is our screen. So this is at this point. What is the intensity of the light? What is the distance? Distance is nothing but y equal to d by 2. Y equal to d by 2. You have to find intensity formula. Intensity equal to 4 I naught. 4 I naught cos square 5 by 2. What is 5? 5 is nothing but phase difference. Phase difference. How to find phase difference? Phase difference phi equal to 2 pi by lambda into delta x. What is delta x? Delta x is nothing but path difference. Okay. How to find path difference? So see, phi can be written as 2 pi by lambda into path difference yd by capital D. But what is y? D by 2. What is y? D by 2. So substitute the values, all values. 2 pi by lambda 6,000 into 10 to the power minus 10 into y. Y is nothing but d by 2. Y is nothing but d by 2, that is 1 milli. So I am writing here 1 milli is minus 10 cube into by capital D. What is the value of capital D? 10. This is our 10. If you solve this one, you will get a value 3 pi by 2. 5 value you will get a 3 pi by 2. 2 pi by 3. See. You will get the value as 2 pi by 3. So cos square 2 pi by 6, that is nothing but pi by 3. Pi by 3 can be written as 1 by 2 whole square. 1 by 2 whole square. So if you substitute in this equation, you will get cancelled out this 4. Then you are getting intensity as I naught. Option 2 is your answer. Next question. 43. What they are asking? They have given a graph between pressure and volume. What they are asking? See here. 10 mole of an ideal gas is undergoing the process as shown in figure. The heat involved in the pressure from P1 to P2 is alpha. Heat involved. What is the formula for heat? Q can be written as CV N delta T. CVN delta T. So if I add and multiply, if I divide and multiply with R, N R delta T into CV, I am dividing with R. What will happen? So see here, PV equal to nRT. So from this one, Q can be written as CV by R P2 minus P1 into V. What is V here? V is 1. This is 1. No need to consider. CV, they have given already. CV equal to 21 by, what is R? 8.3. What is P2? P2 they have given already 30 minus, what is P1? 21.7. If you subtract, you will get 8.3. 8.3 get cancelled. Then value of alpha is nothing but 21. Is nothing but 21. Next question, 44. Question number 44. Very beautiful question. See here. The velocity and the distance graph they have given as shown in figure. Which graph represent the acceleration versus the distance? So observe here. We are having some constant value, but it is a negative slope. It is negative slope. So what is the value? Velocity can be written as minus mx plus c from this graph. What is the acceleration in terms of velocity? Acceleration can be written as v into dv by dx. What is the value of dv by dx? dv by dx can be written as, from this one, minus m. Then acceleration can be written as, you have to substitute v, minus mx plus c into minus m. You will get m square x minus mc. This is our graph. What is this graph? I don't know. So slope is positive. Here slope m square is positive, and we are having one more intercept, that is a negative intercept. If you observe the equation y equal to mx formula, that is it's a straight line. It's a straight line. So it's a straight line. This is constant, or this one. No negative intercept here, no negative intercept. So option 2 is having negative intercept. Next, question number 45. The distance between an object and 3 times magnified real image is 40 centimeters. Magnified real image, m equal to minus 3 equal to v by u. From this one you can simplify v equal to minus 3u. Distance between the, so magnitude of v minus magnitude of u can be written as 40 centimeters. So substitute here, 3u minus u equal to 40 centimeters. U can be written as 20 centimeters. If u is 20 centimeters, what will be v? V can be written as minus 60 centimeters. What do you have to find? You have to find the focal length. What is the formula for focal length? Focal length 1 by f equal to 1 by u plus 1 by v. So substitute the values, 1 by minus 60 minus 20. Minus 60 minus 20. So you are getting minus 1 by 15. F can be written as minus 15. Question number 47. A point charge 1 microcoulomb is located at a 2 centimeter distance from the one end of the thin insulator wire of a length 10 centimeter is having a charge. The rod is having charge 24 microcoulomb, is distributed uniformly along its length as shown in figure, the force between Q and wire. Force between Q and wire. This is our point charge, but we are having a rod length 10 centimeter of having charge 24 microcoulomb. You have to find the force between these two systems. Let's consider some small distance at dx. This is our dx distance. If you find a df force and integrate it, you will get the total force. See here, F equal to integral df. Before going to solution, lambda can be written as Q by L. That is nothing but Q equal to dx. Q equal to lambda equal to dx. From this one, Q can be written as lambda dx. Q can be written as lambda dx. So F equal to integral 2 centimeter to 12 centimeter, 2 centimeter to 12 centimeter, K Q into one more Q, lambda dx by x square. So from this one, take it out. That's a Q, K, Q, lambda. 9 into 10 to the power 9, that is nothing but K. Q, they have given 1 microcoulomb, that is 10 to the power minus 6. And one more is there, lambda. Lambda is nothing but Q by L. What is Q? Q of a rod. 24 into 10 to the power minus 6 by L. L is nothing but length. They have given 10 centimeters. 10 into 10 to the power minus 2. What is this one? Integral x square. Integral x square. You will get a minus x. Minus x formula I am substituting here. First lower term 1 by 2 into 10 to the power minus 2 minus 1 by, what is the length? Length is nothing but 12 into 10 to the power minus 2. If you solve this entire thing, you will get the answer as F equal to 90 Newton. F equal to 90 Newton. Your answer is 90. Next question. In meter beach, the experiment is to determine value of unknown resistance. The first resistance 2 ohm and 3 ohms are connected in the left and right. This is 2 ohm and this is 3 ohm. 2 ohm and 3 ohm. Left and right. Obtain the gaps of bridge and null point is obtained at a distance L centimeter from the left. So this is obtained a length L centimeter from the left. In this one you are having 10 minus L. Okay. Now when unknown resistance X ohm is connected parallel to the 3 ohm resistor. When we are connected X ohm resistor parallel to 3 ohm, then the null point is shifted by 10 centimeters. The right wire, it is shifted by right wire, the value of unknown resistance. The value of unknown resistance. See here, first case 1, 2 by 3 equal to L by 100 minus L. That is nothing but L equal to 40. L equal to 40 centimeters. What is case 2? Case 2. 2 by, what is the equivalent resistance here? 3x plus 3 plus x. 40 plus 10 minus 60 minus 10. You will get a 1 here. And 2 equal to 3x by 3 plus x. If you solve this one, x you will get a 6 ohm. What is the value of x? X is nothing but 6 form. That is your answer. Next question, 49 question. A uniform cylinder of length capital L and a radius capital R has moment of inertia about axis I1. A small concentric cylinder. This is our big cylinder. Okay. Concentric cylinder of length L by 2. One more is there, cylinder. Concentric cylinder is there. This length is L by 2. This length is capital L, which is having R. And what is this R? R is R by 3. R by 3 is curved from the cylinder, has the moment of inertia about its parallel. So this moment of inertia, bigger one you are having moment of inertia I1, small one you are having moment of inertia I2. So then the ratio of I1 by I2. What is the ratio of I1 by I2? I1 m r square by 2. I2 I am writing here. I2 can be written as, from parallel axis theorem, I2 can be written as small m r square by 9 into 2 by 9 into 2. What is small m? So the mass can be written as rho into volume, that is nothing but 4 pi r square into L. 4 pi r square. What is r here? R by 3. So r square by 9 into L. What is L here? By 2. So this is your capital M. So capital M by 18. Capital M by 18. So substitute here capital M by mr square by 18 into 2 into 9. I1 by I2. So I am writing here I1 mr square by 2 by I1. So this is our I1 by I2. If we cancel these two, 9. So 9 into 9, 81. 81 into 2. What you are getting? 81 into 2. 1. 81 into 2. 162. This is your answer. 162 is your numerical answer. So next one, see here. 50th question. A soap bubble of a surface tension 0.0 Newton per meter blown to diameter of 7 centimeter. If they have given value microjoules of work done is done in blowing the further to make a 400 diameter. So they have given work done value. How much work done makes 2? So see here. This is our work done value. You have to find the x value. First we have to find the work done, and then you have to equate with that equation value, and you have to find the x value. Work done can be written as, in case of soap bubble, 2T, that is nothing but surface tension into area. Surface tension into area. Area of first pi r2 square 4 pi r2 square minus 4 pi r1 square. So simply you can say this one 8 into tension 0.04 into pi 22 by 7. Pi is also common. You can take common. And R2 square. R2 square is nothing but 14. So I am writing downwards. See here. 14 into 10 to the power minus 2 whole square minus 7 into 10 to the power minus 2 whole square. This is multiplied by this one. So this is our work done. If you solve this work done, you will get the value as 3696 into 10 to the power minus 6 joules. If you equate with this equation, okay, you will get the x value as 110,11304 microjoules. That is your answer. So this is our end of the session. If you are having any doubts, please comment below. Thank you so much for watching.